Hi, everyone. I'm happy to be here. Thank you for joining at this time. We're competing with lunch. That's always hard. I'm Tomer Steinberg. I'm a solution engineer at Snowflake. I've been working together with Toyota Motor Europe over, almost the last 3 years. And I'm happy to have Jeroen here with me.
Hello, everyone. I'm Jeroen. I'm from Sigeka and a contractor for Toyota for the last 3 years. Nice to meet you all.
Yeah, so we're going to talk about how Toyota used Iceberg with the Toyota connected cars. Let's talk about the story so far. What are the challenges that we've had? What is the architecture vision that we had and have now? What are the use cases that we implemented, and also what are the use cases that we'll implement in the future? Just like any big, large company, Toyota has many different systems that are managing sales, service, marketing, vehicle profile, supply chain, you name it. And often with such companies, these are siloed in on-premise systems, siloed in the cloud, on AWS, on Azure. And also you have different types of silos, like BI tools, Power BI, which are taking a copy of the data, or people downloading data from systems into Access, into Excel sheets. That poses a lot of challenges to companies and also for Toyota. The type of challenges that we had were challenges which are related with quality, challenges that are related with trust, challenges that are related with governance. Toyota is a European company. Well, as well as a European company, they're compliant. They have to be compliant with GDPR. This means that they have to get approval from a customer to anything that they're doing with the data. Everything has to be legitimate. Everything has to be consented by the customer. They need to be able to prove it. Therefore, when you have silos, it's hard to fix data quality issues. It's hard to delete data. It's also hard to use data efficiently. And this new architecture that we designed is there to help and solve those problems. And for some of you guys who have attended the previous session, you ran over from Thierry's and Deloitte session, this might be a recap, but in this data mesh architecture, in general, every team, every domain is responsible of building data products. These data products have to be, it's just like selling a data or selling a product on Amazon. You have to anticipate what your consumer will want. You have to anticipate what's required, what's the required latency, what's the required data quality, etc. And in this architecture, each domain or each team has its own database in Snowflake, in which they are ingesting data, in which they are fixing, modeling, creating high data quality data sets, and then they're documenting the data, publishing in Collibra Marketplace, setting the strict governance procedures, strict governance defined by Toyota, and then those data products are able to be discovered by consumers who are using, for example, Power BI, or a data scientist who's using Dataiku in order to build a new data product or a new AI data product. This could be consumed by another domain, another team, to create a more complex and more valuable data set, and then, again, republished into the marketplace. This data mesh is really helping Toyota scale. It's helping 28 national sales and service companies to use data efficiently, to use high-quality data in order to boost their decision speed, in order to make better decisions. It's also powering 8 manufacturing plants. It's also powering Toyota Connected or other Toyota affiliates, like insurance, like financial services. And this data mesh together, so this technical architecture together with the business definitions, is helping Toyota really utilize data in a better way. Let's specifically talk about connected car. So what is this data set? So typically, it's a high-volume data set, which is also very high value. This means that it's anything, any sensor that comes from your car is being collected, then being uploaded to the cloud, and it's really helping Toyota create better data sets, better and safer cars, better customer experience, better driving experience. But this data set is also very challenging. It means that it's high volume, petabytes. Petabyte means that it's very hard to make copies of it. It's expensive to make copies of it, so you should avoid it. It's hard to analyze this data set in real time. Making duplicates is also challenging in terms of governance, and you want to avoid the silos as much as possible. By definition, this data set has to be analyzed with consent. And to get value from it, it has to be analyzed with consent and other data sets, like service, like supply chain, like marketing, for example. So it is a fundamental data set in order to activate the data mesh and other domains and other consumers in the Toyota organization. Let's talk about the architecture vision. The first architecture that we designed it 2.5 years ago, was really way before Apache Iceberg was common. Snowflake didn't support it at the time, so our plan was to make an aggregated copy of it, connect it with consent, and then expose it in the data mesh architecture in the Collibra marketplace so it can be consumed and governed with the Toyota data mesh. This means that it would have been governed, it would have gotten good performance, but at the price of making the copy. It's expensive, it's also hard to amend, hard to fix. So that's something to keep in mind. However, luckily, in the last 2 years, Snowflake has invested a lot in working with Iceberg. This means that this Iceberg evolution allowed us to make 0 copies, allowed us to get great performance, allowed us to get governance, so no compromises. So in this case, we're having an S3 bucket, which is mapped against an external volume. We also are using the Glue catalog on AWS, which is integrated with a catalog integration to Snowflake, and then an external table is defined on top of this data set. Then from that moment, this is governed. We can see who can access it. We can set masking policies. We can set row level restrictions. We can set any of the Horizon catalog capabilities in order to use it. And it's then published with Collibra. And the only difference between this one and a Snowflake regular table is that this is read-only. I'll hand it over to Jeroen to explain how this is being technically constructed.
Thank you, Tomer. So, are we at the right slide?
Yes, that's
yes.
the right slide.
Good. So, over the next couple of slides, I would like to show you how easy it was for us to integrate existing Iceberg tables in combination with a Glue catalog in AWS. To give you an idea, it took us a few days to perform the end-to-end setup and query the billions of rows for the first time in a cross-region setup from Frankfurt to Ireland. So let's move over to the configuration. The first part we need is the catalog integration. The catalog integration acts as a gateway to all of the metadata stored in the Glue catalog, and you could set up an automated refresh of the metadata in case the data changes. The second part we will be needing is the external volume. It will just allow us to read the data in the S3 bucket. So moving on to step 2, once we did the setup, we need to grant the privileges in AWS so that Snowflake can do their thing. So for both components, we will be needing the user and the external ID that you can find through a describe command in Snowflake. So for the catalog, it's straightforward. We describe and you can fetch it. The external volume, there the user and the external ID are a bit hidden away in the storage location, and you can find them through parse.json easily. Now, once the cloud team did everything they had to do, we were ready to go. So in this create statement of the external Iceberg table, we need to fill in the external volume, the catalog, the namespace, and obviously the table name we want to virtualize. And if we would like to use the automated refresh from the catalog. And once that's done, yeah, we were ready to select, in this case, the dummy data for this presentation, but also the real data. Now, moving on to our architecture for sharing. As already mentioned in previous sessions of TME, sharing is crucial, and especially in a data mesh setup. So on the left, the car comes in, the data comes in, it goes to the Iceberg setup from Toyota Connected, which is a separate company. In there, we will virtualize in Snowflake then all of the data through an external Iceberg table in a dedicated landing zone. This landing zone, only the data ops team can access that. Why do we do that? It would be too tough to manage the security if we would allow all of the data mesh people access to it. So from those external tables, we create views to the domains. To give you an idea, we are currently serving 62 domains across TME and all of the national markets attached to it. So once you have the data can have row access policies, masking policies, or even remove columns if it's legally not okay to use. Right, now, let's move on to the demo. Let me first log in. All right. Okay, so for the demo, we will start in Colibra. In Colibra, we capture everything concerning the data mesh. What you see here are all of the domains. If we click on them, you will go to their data products, to their metadata, to everything. On the right, you see the marketplace. It's like a bit of Amazon shop feeling. People can go to there, they can request or buy the data after a legal approval. But what's most important for this demo is the last step, so the TCU Iceberg tables. And here, if someone wants to know, okay, Jeroen, which data do we have? They go to there, they explore, and they request it. How does it look like? It's like this. I chose the tile setup now, but you can choose the layout how you want. People can explore, they can see the descriptions and so on, and then know what the data is all about. Now, let's move on to Snowflake. So let's say for the sake of this demo, a Belgian analyst wanted to know the trips passing through Belgium. They were only allowed to see the first 5 characters of the VIN and all the trips passing through Belgium. So how do we do that? Normally, we should do it in dbt, but for the sake of this demo, everything is in Snowflake. So the first thing we do is create a masking policy that will show the first 5 characters of the VIN and replace the rest with a character how we want. The second one is a row access policy, which does an array contain of all the trips passing through Belgium. Now, what we do then, we create a view in the domain. Again, it should be done in dbt, but for the sake of this demo, we do it here. And then we alter the view and apply the policies. Now, how does it look like? First, I will go as the admin. I should have it. Yes, perfect. And then you can see that all of the countries should be visible. Again, it's dummy data, so you will see strange things. But the first row, for instance, is France to Belgium, but you also see Italy, Spain, and so on. Now, if we go to the domain, and we use that role, you will see that only they are allowed to see the Belgian data. So here you see trip through Belgium, Belgium. Again, it's dummy data, and the first 5 characters of the VIN with an aggregation of the total duration of the trips. Right, now moving back to the slides. Perfect, so how did we achieve our operational efficiency? I'm not going to go in too much detail because I see we are already running on a tight schedule, so zero copy. If you went to the session of Thierry and Magali earlier, you see there is a big importance of ingesting only once, or in this case, virtually only once, and share it to the teams. Minimizing the risk, meaning, okay, we need to have a good governance, right? And the privacy by design. No silos, so every team needs to be able to access the data, explore the data, and see what's in there. We need to keep it simple. So again, the setup is quite straightforward because it would be unmanageable if we had something complex for 62 domains. And fast time to insights. With the automated refresh of the Iceberg tables, we do not have any more delays in ingesting, processing, and whatever. We can straight access the data whenever it's processed on Toyota connected site. Right. So before we go to the use case, I want to show you the end-to-end flow. The car starts to drive. It connects binary data. It stores it in the local memory. Once the car is parked and the ignition is turned off, the data will be sent to the cloud in a binary format. So once the data arrives in the cloud, we will do some decoding, and we will generate actionable insights out of the binary data. So for the architecture, the binary data comes in at Toyota Connected. In their Spark jobs on the EMR, will decode the data, and they will apply a medallion architecture, so raw, silver, gold. In Snowflake, we then have the setup we described earlier, and we would connect to the silver and the gold layer. Why is that? Sometimes it might be that we need to decode some more. TCU did something, but we need more insights, and we decode it ourselves. The gold layer could be that they had some reporting data already lying around, and we could use it for our reports. Now, let me talk about the use cases that use this architecture. So the first one is connected vehicles. That one shows how many cars are connected and so on. And to give you an idea, it generates about 2 to 3 billion rows on a daily basis in events. And on an annual volume, we have around 750 billion to 800 billion. I see it grow every day. The second one, it was already touched upon on the keynote. It's automatic crash notification. I think the name says it all. It will show if a crash got detected and so on. So the last one is PHEV, which stands for plug-in hybrid insights. It will show how good someone drove with their electric car, how many miles were written with the battery and so on, and the fuel consumption. Okay, now moving on to a road ahead. So our road ahead is integrating Stream Native with our open catalog. TME, or Toyota Motor Europe, uses Stream Native to do a lot of things. They have Pulsar on top of it, and they will stream their data. So when we saw that Stream Native had an open Iceberg, or an open catalog integration, we said, hey, let's do it. We don't want to duplicate the data again. They will stream it to their S3 bucket and use our catalog. So whenever we need the streaming data, we just simply go to there, fetch it, and do some things with it. So you might be wondering, okay, but which use case are you using for this? I don't know if everybody knows here, but Toyota Motor Europe also sells charging stations for at home. So one of the use cases is a charging data that comes from the car, right? And then we could do some KPIs on top and know what happens. All right. And then what's it actually? Thank you very much.